In section 3.5, we talk about equations of lines. So the first thing we're going to do is we're going to graph a line using its slope and its y-intercept. This tends to be the easiest way to graph a line when given an equation. So we have the function y equals 1/4 x minus 3. So let's go ahead and pull out what the slope and the y-intercept would be. So remember, the slope is the coefficient of the x term. So in this case, my slope is 1/4. My y-intercept is the plus or minus part that comes after the x term. And so in this case, my y-intercept is the point 0, -3. And so when we use the slope-intercept form to graph a linear equation, the first step is to plot the y-intercept. So let's go ahead and do that. We got 0, -3. And then we're going to use the slope to find the next point. And then you'll draw a line through the 2 points. So looking at the slope, we have 1/4. And so that means I'm going to go up 1 unit and to the right 4 units. So from my y-intercept, I'm going to go up 1, and then I'm going to go over 4. And then I plot my next point. Now we can keep doing this trend. From the point we just found, we can go up 1 unit and to the right 4 and plot another point. Now if you notice, I could have gone another direction. So when I go up 1 unit and to the right 4, that's positive over positive. But I can also get a positive number by doing a -1 divided by a -4. And so that means that I can go down 1 unit and to the left 4 units as well. Either direction will get me a point that is on my line. So if I go down 1 unit and then I go to the left 4 units, you'll notice that my point is going to fall on my line. And so I'm just going to go down and then over to the left 4 units again. So you can see that it doesn't matter which way we do this. And so when I connect all of my points, that is what my graph is going to look like. Let's go ahead and graph 2x plus 3y equals 12. We want to convert this into slope-intercept form, which means we need to have y by itself. So let's go ahead and move 2x from both sides by subtracting 2x. So we have 2x is canceling on the left. We have 3y equals -2x plus 12. And the last thing we can do is divide everything by 3. And so it cancels on the left-hand side. We have y equals -2/3 x. And 12 over 3 can simplify as 4. And so my slope in this case is negative 2 over 3, and my y-intercept is going to be 0, 4. So let's go ahead and plot our y-intercept first. And then let's look at our slope. We have negative 2 over 3. So that means I'm going to go down 2 units and to the right 3 units. And so starting from the y-intercept we plotted, we're going to go down 2 and then to the right 3. And that's going to be our next point. And so we can always do this again, go down 2 units and to the right 3 units and get our next point. But just like in the previous example, we have another direction that we can go. So remember that with negatives and fractions, we can move the negative to the bottom and it won't change the fraction at all. So we could write 2 over negative 3 instead. But this means that you would be going up 2 units and to the left 3 units. And so let's go ahead and see what that looks like. So from my y-intercept, I'm going to go up 2 units. And then to the left 3. And you'll see that it would fall directly on the same line. So let's just do it one more time. Up 2 and to the left 3. And so when I plot my points and connect them, I end up with this line. Now what about using slope-intercept form to write equations of lines? So we may also use slope-intercept form to write the equation of a line given us its slope and the y-intercept. So just as a reminder, slope-intercept looks like y equals mx plus b. And m is the slope and b is the y-intercept. So if we have a y-intercept of 0, negative 3, and a slope of 1/4, how would we write this? Well, the part we care about in the y-intercept is the negative 3 portion. And so that's going to become our b. My slope is 1/4. This is my m. And so plugging it into our slope-intercept form, we have y equals 1 over 4x minus 3. We do have another form for equations of lines, and this is called the point-slope form. So when the slope of a line and a point on the line are known, the equation of the line can also be found. And so the point-slope form of the equation of a line is y minus y1 equals m times x minus x1. And so the slope is still your m, and your x1, y1, or the point that you have, is what will change. The y and the x's without those little subscripts will stay the same. They don't change in your equation. So let's find an equation of the line through the points 4, 0, and negative 4, negative 5. And then we're going to write the equation in function notation. And so the first thing we need to do is we need to find the slope, because we aren't given it, we're just given 2 points. But we do know how to find the slope of a line with 2 points. And so I'm going to just write down the slope formula so we have it. And I'm going to label my points x1, y1, and x2, y2. And so let's go ahead and find the slope first. We've got y2 minus y1. Well, that's -5 minus 0 divided by -4 minus 4. Well, the top ends up giving me -5, and the bottom ends up giving me -8. But I have a negative on the top and the bottom, and so we end up with just +5 over +8. And so this is my slope. We will be plugging this into the m portion of our point slope form. And so it does not matter which point I pick to plug into my formula. We could either pick the one that's already labeled as x1, y1, or we can pick the x2, y2. It does not matter. Once you simplify, you get the same exact answer. And so I'm just going to plug in the x1, y1 that I already have labeled. And so here's the formula for point slope. And we need to plug in m and x1, y1. So we have y minus y1, which is 0, equals m, which is 5 over 8, times x minus x1, which is 4. And so we want to write this in function notation. Well, function notation means that I have f of x equals. And f of x is just another way that we can write y. And so really what we want to do is we want to put this into slope-intercept form. Or we just want to have y by itself. And so y is pretty much by itself because it's y minus 0. And so we get y equals 5 over 8. And I want to make sure that I distribute this to both pieces. And so I have 5 over 8 times x. And then remember, when we multiply with fractions, we multiply across the top and bottom. And so we have 5 times -4, which is -20, all over 8. Since we can always write this with a denominator of 1. And since we're using function notation, all we have to do at this point is we just need to put f of x instead of y. And so we get f of x equals 5/8 x minus 20 over 8. And we can actually simplify that 20 over 8 just a little bit. We can take a 4 out of the top and bottom. And so we end up with f of x equals 5/8 x minus 5 over 2. And so the tip just says that if 2 points are given, you can use either one in point slope form, because when I simplify, I end up with the same exact function. Now what about writing equations of vertical and horizontal lines? So let's find an equation of a horizontal line containing the point 2, 3. And so when I'm looking at this coordinate, what is the piece that I care about when we talk about horizontal lines? Do I care about the x coordinate or do I care about the y coordinate? Now, we know that horizontal lines are in the form y equals c. And so do you think I care about x or y? I care about y. So I really don't care about the x coordinate here. And we can just write this as y equals 3. For example number 6, we're writing an equation of a line that is going through the point 2, 3 again, but it has an undefined slope. And so the undefined slope tells us that this is a vertical line because vertical lines have undefined slope. And we know that vertical lines can be written as x equals c. And so do I care about the x or the y coordinate on 2, 3? That's right, we care about the x coordinate. We don't care about y. And so we can just write this as x equals 2. And for the last one, we want to write a function that describes the line containing the point 4, 4, and then it's perpendicular to 2x plus 3y equals negative 6. So what we can remember from perpendicular lines is that they have opposite reciprocal slopes. And so what we need to do is we need to find the slope of the equation of this line that was given to us. 2x plus 3y equals negative 6. And so we're going to put this into slope-intercept form. We've got 2x plus 3y equals negative 6. So the first thing we can do is subtract 2x from both sides. And so it ends up canceling on the left. We're left with 3y equals negative 2x minus 6. And then we can divide everything by 3. And so it ends up canceling on the left. And we get that y is equal to negative 2/3 x minus 2 when we simplify. And so the slope from this, which is the coefficient of x, is negative 2/3. And so that means that the perpendicular slope, which we usually will designate with this upside down T symbol, is the opposite reciprocal. So we're going to change it from negative to positive. So now it's a positive slope, and we flip the fraction so that we end up with 3/2. And so I'm given a slope that I just found, and I'm given a point. That point was 4, 4, And so since I have a point and a slope, I can put this into point-slope form, which as a reminder is y minus y1 equals m times x minus x1. And so let's go ahead and plug this in. We've got y minus 4 equals 3/2 times x minus 4. And so we want to distribute the 3/2 into both pieces. We've got y minus 4 equals 3/2 x. And remember, we can always write this with a denominator of 1, so we can multiply here. We've got 3 times negative 4, which is negative 12, and then 2 times 1, which is 2. And so really what we end up having is y minus 4 equals 3/2 x minus 6. And the last step is to add 4 to both sides because we want to get y by itself. So we can put this in function notation. It ends up canceling on the left-hand side. And I'm just going to go ahead and replace the y with f of x equals 3/2 x minus 2.